Hello, everybody. This is Quad Hopkins back for another RHCSA style exam. Today, we're going to wrap up LVM and resizing LVM. Today, we're going to do our last one. We're going to be doing LVM and resizing lab using FDISK. Uh, so. As you guys seen from my several videos on LVM, reason why I want to really hone in on LVM is because it is a very highly weighted and a lot of points on the exam for LVM. So on this lab, we're going to use several different disks instead of along my previous videos we've had just one disk. And now we're going to do, I've added an additional couple disks on here. So in this lab, we're going to be partitioning the NVMe disks. We're going to be creating a PV, a VG, which is volume group, physical volume group, and volume group. I'm sorry, physical volumes, volume group, and LVM. And we're going to be mounting them persistently and again, in the fstab. We're going to extend storage using additional disks that I've created. We're going to grow the file system. So let's go ahead and take a look here what we're going to be working with today. So in order to look at this, we're going to use LSBLK. Okay, so in my previous lab we have NVMe NO0 and 2. I at this morning I've added just a couple 5 gig disks, N3 and N4 this morning. So we're going to be we're going to be expanding disk using one of these disks here, these 5G disks that we're going to be using. All right, so enough of that. You guys know how this works, so let's just let's get to it. So let's go ahead and start with partitioning our first disk. All right. So let's go ahead into partitioning our first disk. Let's go use the fdisk command. Fdisk. All right, fdisk. All right. /dev slash. Let's go ahead and copy and paste this NVMe. All right. Uh, NVMe. That way, I got this here. NVMe. All right. All right. NVMe. All right. All right. So now we're in an interactive mode here. So what we're going to do is, all right. So what we're going to do is we're going to use the full disk here for this one. So we're going to create a new partition, and then we're just going to accept the defaults. Use partition. We're going to use the same one. We're using the first sector, and we're using the entire full disk. So we're just going to default. We're going to default to that. All right. All right. So contains VFAT signature. Do you want to remove it? Yes, we do, because we're not working with VFAT. All right. So I want to do yes. All right. So now I want to change. I just want to print. All right. Now let's change the type. So T for type. Let's do capital L to list the types. So we want Linux L. We want the LVM LVM. So let's look at that one. So let's find the hex code for that one. All right, so what we want here, hex code LVM, you know. Oh, okay, AE. All right, so oh yeah, it's sitting right here looking at my face. All right, so we're going to use 8 AE for Linux LVM. So we're just going to we're just going to use the hex code. We're going to use AE. All right, and then we're going to write, what we're going to do, just going to write to it. All right, okay. Now let's go look at the partition we have. All right, so let's go ahead and verify work. LSB okay. All right, all right, there we go. Okay, now, okay. So now what we want to do is we want to create a physical volume from this partition we've created. All right, so you guys know the workflow. All right, so we're going to do create, pv create. All right, /dev /NVMe 0 and 2p1. All right, that's created successfully. All right, so let's go ahead and create a VG group. So let's do VG create. All right, and we're going to name it. Let's just name it VG data. VG data /dev /NVMe into p1. All right. All right. VG cells correct. Now let's create the logical volume. All right. So what we're going to do is let's go ahead and use LV. All right. Create. Now just pay attention to the commands here. So we're going to use the capital L for the size. Now, when you're working with physical extents, you're going to use a lowercase l. So we're going to use L, and then we're going to put 10G. All right. And then specify the name of the LVM we're going to do. We're going to use LV data. And then we need to specify we're going to the group VG data, VG data. Ooh. Hmm. Oh, well. Oh, VGG data. All right. We'll use it. We'll use the VGG data. I won't. We'll use that one. All right. All right. So that one's created. All right. So now let's look. Now, always want to verify your commands. I'm going to use for physical volume. I'm going to just use the display. It gives you. I like it because it gives you more. It gives you more information. Um. Oh, PV. Oh, PV display. All right. Let's go ahead and clear this. All right. All right. PV display. All right. As you can see, this is our P1 here. This is our free physical extents, total physical extents. All right. Now let's go to VG display. All right. Here's a VG display. Here's our group up top. Again, this is our physical extent size is 4 MB. So when you create a physical volume group, it does take that use 4 MB for space, allocate that block of space. So we VG display, let's do LV display. LV display. All right. So that's our system one. All right. This is our LV display. Our size is 10 gig. All right. So that's what we wanted. All right. So let's clear. Okay. Now that we verified our work. So always want to verify your work, especially, any exam you take, always want to verify your work. All right. So next in this LVM flow workflow, we're going to format the file system, and um, we're going to use XFS. So now for us to do that, we need to make a mount. We're gonna make a mount point. So let me see if there is a directory, because on the exam, don't always assume, from what I've heard, don't always assume that these directories are going to be created for you. So just make sure, all right, there's no such data. Okay. So let's go and make a mount point, mkdir dash p, and we're gonna say just slash data. All right. All right. So now we want to make the file system. So we're going to use mkfs, make file system. All right. And the extension we're going to use is XFS. XFS. All right. Slash dev. All right. Slash VGG, VGG data and LV data. LV data. All right. There we go. Success. So we made the file system. Okay. All right. So now we can verify. You use the df, all right, dash he and slash data. There we go. So we have size 35 gigs. We use 5 gigs available, 29 gigs, and we set percent, and it's not mounted yet. So, all right, so let's clear. Okay, so again, so now let's go ahead. Oh, I forgot to do that. Okay, didn't want to do that. Okay, now let's make this persistent. Oh, I had some steps here. Forgot a step here. Always. So I already made the mount point. Okay, so let's mount the LV data to data file. So that's why it didn't work. I missed a step. All right, so let's go ahead and mount. So we're going to do m mount. All right, slash dev. All right. Remember, this has become muscle memory for you. BG, uh, BGG data and LV data. All right. And then we're going to we're going to mount it to data. All right. fstab has been modified, but system still uses old version. Okay, don't worry about that. All right. So even though it's mounted, again, as you guys will know, even though it's mounted, if we rebooted the system, definitely all the work we've done, we will be removed. All right. So in order to do that, we're going to persist. We're going to add we're going to add that to the FS tab. So we're going to do this a little different way. You can do it many different ways. You can use the block ID to make it persistent, or the file path. But let's just use the block ID. I always like using it. It's more of a engineering, looks cleaner looking, looks better looking than just mixing up UUIDs and file path. So in order to find a block ID, you want to use BLK ID. All right. So what we want to do when we want to specify the device path, VGG, LV data. There it is. All right. So let's go ahead and copy that UUID, copy that, and let's another space. So it's gonna go VI slash etc slash FS tab. All right. So let's insert mode. All right. Let's copy that here. Let's copy. All right. Get rid of the quotes there. All right. So next we want to specify the mount point data. All right. Then specify this file system we're using, XFS. And then what we want to do is just the defaults, and then 0 All right. All right. So then now we're going to escape WQ to write. All right. So it's mounted. So we're going to use the command. All right. Use that. So let's see. So use the df-h/data. All right. All right. Now device map. So this is the device mapper path. All of that is like more of a symbolic link. All right. So let's go ahead and just make sure we just use mount -a. All right. I just use system CTL. Let's just for sanity check. You don't have to do this, but daemon reload up system CTL system. All right. Daemon reload. All right. Should be good. Just another mount just for sanity check. All right. So that's clear. All right. So let's do an LSBLK. There we go. Mounted. There we go. Again, this mapper path is basically this is like a more of a like a symbolic link. So let's go ahead and extend LVM using our NVMe N3 disk, which using that 5 disk. All right. So to do that, so what we want to do again, want to do a fdisk and /dev. All right. Slash NVMe 0N3. All right. Want to use that. All right. So again, we want to push new, one new. All right. Enter, enter, and we want to enter. Yes, we want to remove that. Yeah, we're not using that. Now, if we have these signatures, say, if we want to keep, like, say we're adding uh additional size on adding more gigs, we want to keep that data, you might want to choose no instead of yes, because if you choose yes, you'll lose all that data. So we're just gonna override it. We don't need it right now. We have nothing, no data to enter. All right, so let's just change the type. All right, we're going to use 8E for LVM. All right, P for print. All right, so W for write. All right, got that. So we're going to do another LSBLK. There we go. All right, so we're going to add this physical, this partition. We're going to first create a physical volume of that, and then we're going to add that to the existing to that data to the VG data. So what adding this disk will expand that volume group. So it will expand, give it more space. So in order to do that, we're going to first remember we're going to use create /dev r/ all right n NVMe 0N3 P1. All right. Create it. Now we want to add it. So to add it, we're going to use VG extend. We'll use VG extend. All right. And we're going to specify the VGG data I've created by accident. So we're going to use that. So dev slash NVMe N3P1. All right. All right. Volume group has been successfully extended. Now, next, we want to create next two steps, you can do these in one command or two. So we're going to do this in one command. So if you want to make it the first solution you can do is you can create the LVM, specifies the additional size, and then you would want to grow the file system using XFS underscore grow FS. But we're going to bypass that. We're going to do this in one command. So that way we'll knock this out in one command. So we're going to use LV extend, All right, capital L. Now, be important. We want to add a plus because we're adding 3 gigs. We're adding 3 gigs, 3 gigs to the logical volume. All right. So we're going to use slash dev slash NVMe 0 and 3P1. Oh, nope. Specify the group. BGD data, LV data. Now, remember what I said earlier. If we just click enter, we will add it. It will add the additional, but we need to grow the file system. So let's do that. Let's go ahead and do that in one command. So we use a dash R. We use the dash R to do this. All right. Now, let's go ahead and do that right quick. There you go. So within that one command, we were able to extend that LV, add the additional 3 gigabytes to the LV data, and also grew the file system in one command. So we went to 10 gigabytes to 313.0 gigabytes. All right. Now, we didn't. Now, typically, if you wanted to do it the other way, you would just, I'm not going to type this in, but let me just put a comment here. You're going to use the command XFS underscore grow FS, and then you're going to grow slash data. This is what you would have to do if I did not include that R in there, that dash R option. Okay. So again, let's go ahead and check our work. So it's VG display. All right. Here. All right. See, physical extents increase from what we had before. All right. So we're going to do LV display. Oh, LV display. All right. Look at that. And then now let's do a df dash h to check or slash data. All right. There we go. So we added it. So remember, it was only at like 17% used, but we've added that 3 gig. So look, it freed up. We have more available. So again, now let's do another one. So let's go ahead and use our last disk. So we're going to add our last disk, NVMe N4, and extend LV to 100% free. So now to do that, we're going to use the fdisk command again, and then we're just going to let's go ahead and ls be okay. So you get a good idea what I'm working with here. So we're going to do a fdisk, all right, slash dev, all right. Now we're going to do slash NVMe 0N4, all right. Okay. So in this instance here, what we're going to do is we're going to create a new partition. All right, with the same thing, enter the defaults, set the defaults. Yes, we want to remove it because we don't have any existing data. All right, one to T for type, and then AE for Linux logical volume, E. All right, and then P for print to show. All right, now we're gonna write to the disk. All right, well, let's do an LSBLK. All right, there we go. All right, so again, same same thing. It's good. This is all the flow. It stays the same. But if you remember the workflow instead of the commands, you should have some success. So let's PV create. All right. Oh, PV create. Oh yeah, PV create. Create. All right. And we're gonna do slash dev slash NVMe NVMe. All right, 0 and 4P1. Yeah, that's the one. Mm-hmm. And 4P1. Yeah. All right. Now now again, we're going to, in order to add this disk to the VGG data, all right, we're going to do the same command again. So we're going to VG and we're going to extend. All right, we're going to extend VGG data. All right, slash dev slash NVMe and for P1. All right, so it's extended. Now again, now again, it's the same step earlier. We're going to do the same thing. We're going to extend the logical volume we're specifying we're using 100% the rest of the free space, and then we're going to grow the file system. All right. So again, so we're going to do LV extend. All right. Now we're using the lowercase l specifying extents. We're using 100% left of the extents we're using here. All right. So next, all right. Oh, let me do for lowercase r. So to do that to grow the file system too. So dash L. This is usually to specify we're adding 100% like all the extents that are left in that. So we're using free up that space. So you want to use specify a capital because we're adding. So 100, all right, percent and free. There we go. And we use slash dev slash NVMe. Oh, VGG. Oh, VGG. Yeah, we're going to every extend and we're going to do that plus free. All right. So now let's go ahead and do it this different way. We're going to do it the other way too. Let's just use the dash L and then we're going to use plus 100, 100 percent free, free. All right. Slash dev slash no VGG data VGG data slash LV data. All right. So it's been successfully resized, but we have to grow the file system. So the reason why I wanted to do it this way, because I want to show the second option of doing it. So we're going to use the XFS underscore grow FS, XFS grow FS, grow file system. And then we're going to specify the mount point theta. There we go. We grew the file system. So those are two different ways of doing it. So if I use the dash R, it would do this and extend it in one command. But I typically recommend just using the dash R. That way you don't have to worry about it. It's already Foster's already grown. So, but I just wanted to thank you guys for joining me on this last lab on LVM. I hope you watch all my LVM videos. I hope it has helped somebody. Again, this is the best way I learn and retain information by making videos. Um, I apologize in advance if I LVM'd everybody to death here in the videos, but again, and make sure because this is again, I can't iterate this enough. From what I've heard and other people who've passed exam is it's LVM is a very you get a lot of points on LVM. So nailing this, knocking this out and nailing it perfectly help you out tremendously on the exam from what I've heard. And so that's what I plan on doing. So I thank you guys so much for joining me. And next video I'll put out tomorrow. I'm gonna be going over a new topic tomorrow. Not sure what that is yet, but I will definitely let you guys know. You know it when I post it. So thank you guys. Guys, enjoy the rest of your Saturday morning. Have a great weekend. Be blessed and have a great week, guys. All right. Bye-bye.